Okay, this is the second video in a series on gas laws, and this one is the other scenario we weren't able to talk about before. Okay, before we talked about when conditions are changing. In this case, what if you have constant conditions? And what that means in a problem is you read it and they say there's one temperature, one volume, one pressure, nothing has a second volume, second temperature, or second pressure. It's all the same. It never goes up or down. Now those cases are usually helpful when you're trying to get something in a lab and measure it. You can use gas laws and gas measurements, like temperature and pressure and volume, to figure out how much of a gas is actually present in a sample. So it's actually very useful. But we try to keep it in a lab where the conditions don't go up and don't go down, because that totally alters everything. So here's what you're going to see. Okay, this is called the ideal gas law, PIVNERT for short, just to kind of remember the formula. And we use this when we only have one of each of those measurements. Now, P represents pressure, as you could probably guess. V represents volume. N, that represents the number of moles. And occasionally you'll have to do a little stoichiometry to figure out what that is, depending on the information you're given. T is temperature. That's got to be in Kelvin. And R is what we call the ideal gas constant. Oops, you know what? I'm just going to erase that and draw a little line over here. Okay. R is the ideal gas constant. It has a lot of different values, and it's just a constant that makes all this stuff work. Okay, we test in the lab. We can see that this is the value it needs to be to match all this data. Now, I've got some units over here that are actually pressure units. These are not the units for the R constant, but this is what we have to look at. How do you know which one of these numbers to use? Because they're totally different. Well, we use whichever one happens to match the pressure units from our problem. So to show you this, I'm just going to show you the setup. I won't go through all the calculations because I don't have a calculator with me, and some of these numbers are not real easy to deal with in your head. But I want you to look at this down here. Okay, if I were given a problem, and I read through it, and it tells me I have a pressure, it tells me I have a volume, and it tells me I have a temperature, but there's only one of each, that's the first thing to do to recognize that I'm going to be using the ideal gas law. There's only one of each of those. No initial or final volumes or pressures or anything like that. Now, if this problem said, what's the number of moles? So basically I'm looking for N. How many moles would be present to make this occur right here, these conditions? Well, I could figure that out. Okay, I take my PV equals nRT, and before I plug any numbers in, I just divide both sides by RT. And what I end up with is N equals PV over RT. So I've rearranged my formula. Now I got to plug some stuff in. Okay, on top I have my pressure and my volume. Now the ideal gas law is very picky. Pressure needs to be in either atmospheres or kilopascals. It's got to match this or this so that I know which R value to use. So in this case my pressure is in atmospheres, 1.2 atmospheres. Okay. And my volume has to be in liters. So if you get a volume in milliliters, you're going to have to multiply it by 1,000 and be able to convert that. I have 0.5 liters. Now on the bottom I have a temperature that happens to be 298 Kelvin. Okay. And then what do I put in for my R? Well, R needs to match my pressure units. So in this case, the pressure, the R that goes with atmospheres happens to be this one. So I put in 0.0821, and I make sure I do this stuff multiplied on top, this stuff multiplied on the bottom, and then I divide them one time, and it should give me a number of moles of a gas. Okay, and we don't know which gas that is. It could be oxygen, carbon dioxide, nitrogen, who knows. That could be something that's told to you in the problem, or maybe it's something you figure out with another step. But this is just the basics of how you deal with the ideal gas law. So to recap, the important things you got to recognize. Pressure needs to be in either atmospheres or kilopascals, okay? Because that's what I have an R value for. My volume needs to be in liters. My temperature has got to be in Kelvin. N always represents the number of moles, and R could be either of those values. It just depends on which one matches pressure units. And once you get those put into place, this is simple algebra, moving things around until you get one variable isolated.